To solve, if I can get my screen to play nicely. Alright, we're going to try to solve this problem here together. This is a tricky one, so I decided just to make a video doing it. I'm using my old program here, so hopefully this goes well, or I have to start all over. Okay, so it wants to know how many times greater is the base of the actual merry-go-round than the base of the scale. So obviously, let's just call this the small and the large, okay? So this is the one on the left is the model of this merry-go-round. So the first thing I see is that this is in feet and this is in inches. So we have to convert them. We have to convert 10 feet to 2 inches. So I'm going to do this properly just in case you all forget how to do this. You're going to multiply times the conversion factor. We want to get rid of feet, so feet go on the bottom. So 1 foot is equal to 12 inches. Therefore, the feet cancel out, and I'm left with 120, and inches are left, so 120 inches. So right off the bat, we had to do a conversion, and I imagine we'll probably have to convert back, but let's take one step at a time. So how many times greater is the base? So we need to find out through proportions, because that's what we've been given. So similar to this, the proportion is going to be area. So we're going to square it. So first, we're given we're given a line, not an area. So this would be like the perimeter and a segment. So remember, those are just kind of 1 to 1, and then we square it. So we're going to look at large to small all the way through here. So large to small, we have 120 inches to 6 inches. Okay, so the large looks like, if we divide both by 6, this would be 1, this would be 20 times. Okay, hold on, let's just divide. Yeah, 20 times. That doesn't sound right for some reason. So 20 times bigger. Hopefully I'm not redoing this later. Oh, I know what I did wrong. And you know what? We're just going to freestyle this. That didn't make sense to me, right? So that is, actually, I like that, because we are going to work through these as if we don't know what we're doing, and that's okay, because we were talking about the perimeter, and now, or the single area, and now but what it wants to know is area. So what I forgot to do was square it, but I'm always looking for myself to make mistakes, and I think that's important for you guys to do too. 20 times bigger made no sense to me, because it obviously to me was much bigger than 20 times. So it's 400 times, because we had to square it. Okay, so all I did was I found the ratio of these side lengths, the 10 feet or 120 inches and the 6 inches, and I simplified it. It just so happened to be 20 to 1, which means that the perimeter of the top of it, or around the circle, is 20 times bigger. So, or just the model itself is 20 times bigger. But the area of the base, because we're talking area, we had to square it, is 400 times greater. And I remember, I believe that's right. I believe that's right. If it's not, I'll be starting over. Okay, so now it wants to know, what is the base of the actual merry-go-round? Okay, so we have to set up large to small again, and now we know that the large, we don't know the large area, but we want to know the large area, so that is our x. The model area is given, so that is 450, and we're going to set up our proportion. So what is the proportion? Well, the proportion is 400 to 1. Okay, so we cross multiply. X times 1 is x, so we're just going to get this answer right off the bat. And then 450 times 400, 450 times 400, and this is how I multiply. It's a good trick. It saves a bunch of work. 16, 18. So it is 180,000 what? Inches, right? We're dealing with inches. We converted to inches. And they, of course, want square feet. Okay, so we have to convert. So 180,000 times our conversion factor, and let's write our. We're going to need our units. So inches go on the bottom because we want to get rid of them. Feet go on the top because that's what I want. And there are 12 inches in 1 foot. But I'm not going to make this mistake again. We are dealing with area, so we must square the. We have to square this factor. Okay. If we were talking about perimeters, we could just do this. But we're talking about, this was actually square inches, and right now we just have inches. So that was another mistake. So I should have written inches squared because that's area. I knew that in my head, I just didn't write it. So I have to square these inches, so I do, and that actually makes my conversion factor, instead of this, it makes my conversion factor 1 over 144, because that's 12 squared. So it looks like I'm going to basically end up dividing, because if I multiply across, I end up with, sorry, it looks like I'm going to run out of room. I end up with 180,000 divided by the 144. By the way, this was inches squared, and this was feet. So let's do this properly. Sorry guys, this one doesn't let me edit, or I might have edited it, but it's evening, so you get what you get. Hopefully this is making sense. You can rewind if you want. I'm doing this right. I just keep forgetting to write the right units. So 180,000, and what is left is feet. So 180,000 feet. Feet. That's what I want. Yeah, so 180,000 over 144 feet. My inches squared are gone. So now I'm going to go ahead and get out my calculator here on my phone. 180,000 divided by 144 is equal to 1,250 square feet. The end. Go team.